Hydropneumatic or booster pump system. Sample. The following example will illustrate the procedure for sizing a system with booster pump as the source of pressure. Assume that there is a 16-story building where the street pressure is reported as 45 psi. The highest pressure outlet is 180 feet above the level of the pump. So, naka-elevate siya. Ito kasi nasa flat yan sa ground floor. Pinakita lang yung top view. Or as a diagram, yung horizontal line, yan yung sa ground. Itong mga riser 1, riser 2, vertical yan pataas. The building has flash valve water closet and the pressure required at the highest pressure is 20 psi. The total combined cold and hot water pressure count for the building is 4840 pressure unit. The length of run from the pumps to the farthest and highest pressure is 350 feet. So, given na dyan. So, kasama yung mga equivalent length dyan. Okay? Material for the water service into the building will be type K, copper tubing, and the water distribution system within the building will be type L, copper tubing. Level 3.5 or figure 4. Ayan. So ito is type K. Paglampas niyan, type L. So unang ang paggawa nyo, gawa ka ng layout na ganito, una nyo nilalagay is yung mga fixture unit. Diba? Ito na yung total ng fixture unit mo. Sa riser na to. Ito naman yung hot water. Sa riser 5. Sa riser 4, ito yung hot water sa cold water. Riser 3, riser 1. Okay? Ang piping niya, ito ganito ang piping niya. Ito yung sa cold water, yung sa hot water, pupunta sa hot water dito. Then, pasok mo dito. Ito yung gamitin mong table, 3.5 or figure para kunin mo yung flow rate. TPM. For example, 1376 FU, this is flash valve water closet. So dito ka kukuha sa may flash valve. And this one is 1376. Yan, in between siya ng 1 to 50 and 1 to 5. Interpolate mo para makuha mo yung value between 240 to 270. This will become 255 TPM. Hot water, dito ka sa kabilang side. Flash tank. So, ilan yan? 896. Between 18,100, so interpolate mo sa 3944, lalabas is yan, 43. 43 gallons per minute. So, lahat to, ganun ang gagawin mo. Lahat ng dinagyan mo ng fixture unit. Total, ito pala, itong 2494 FU is yung itong 1118 mo na. Total to ng 688 at 130. Yan, itong 1118. I-add mo lang yung fixture unit. Plus, ilan to? 2076. So, magiging 2494 itong plus na to. Itong line. I-add mo naman yung 860. So, magiging 3354. Hot water, ganun din. Yan. So, for the pipe sizes, ito na tayo. So, ang mga formulas, calculation mo is F is 0.2083. Ano yung ba? Times 100 over C is 1.85 times Q is 1.85 over D is 4.8655. C is equal to 134 for copper pipes. Sa plastic, iba naman ang value. So, pag gawin mo to sa PPR o yung polypropylene plastic na ginagamit dito sa Pilipinas na for hot and cold, hanapin mo yung C value niya. So, ito lang yung insert mo dito. Plus, siyempre, yung insert diameter, standard na. So, delta P is equal to 0.43TF. So, velocity is 0.4084Q over D squared. For riser 5, check the table. 1376 FU to 55 GPM. Nag-fit is yung 5 size na 4 inches type F. Ayan. Yung type L natin, ang inside diameter ng 4 inches is 3.905 inch. Okay? This is para siyang trial and error. Or ayaw mo mag-trial and error, dapat ang velocity mo is nasa 8. Design velocity mo is 8. So, i-equate mo yung velocity mo sa 8, solve for diameter. Kung ano yung nearest diameter mo doon, up or below, yun ang gagamitin mo. Huwag lang siyang masyadong lalayo sa 8 feet per second. Okay? Pagdating sa maximum. Kaya dito, inalaw pa dito yung mas mataas sa 8 feet per second. Para sa, minsan inaalaw kasi yan. Kung naigsi lang yung pipe. Pag masyadong malang aba, so that is 8 feet per second ka na. Okay. Or depende sa boss mo, sa authority. The maximum is 8 ka lang. So dito, sa example natin is allowed mag ng konti kasi sayang naman ng 5 kunti lang na sa calculation mo 3.2 ginawa mong 4 inches diba? Bawa, compute mong inside diameter is 3.2 so po doon ka na sa 3 inches. Okay, delta P is now 0.433 times 0.2083 times 100 over 130 is 0.1.85 times 255 is 0.1.85 divided by 3.905 exponent 4.8655. So delta P is equal to 2.08 PSI per 100 feet. So, andyan, 2.08 PSI per 100 feet ang unit niya. Okay? So, meron ka ng sa riser 5. Gagamitin mo ito pagkuha ng pressure drop. So, aqua inside diameter. So, riser 3 is 430 FU or 130 GPM. Pipe size is equal to 2.5 and type L. Ito yung nakuha. 2.5. Inside diameter mo is 2.465 inch. So, type L. So, velocity is 0.4084 times 130 over 2.465 squared is 8.74 feet per second. So, above siya, di ba? Pag nag 3 inches ka, mababa yan. Pero, okay lang. Delta P is equal to 0.43 times 0.2083 times 100 over 130 is 0.1.85 times 130 over 2.465 4.8655. The delta P is equal to 5.61 PSI per 100 feet. So, yan. So, mas mataas sa 5 inches. Riser 5 ang pressure drop. Riser 4, 688 FU is 160 gallon per minute. So, pipe size is 3 inches, type L. So, inch diameter is 2.945 inches. Velocity is 0.4084 times 166 over 2.945 squared or 7.82 feet per second. So, delta P is equal to 0.433 times 0.2083 times 100 over 130 is 1.85 times 166 is 1.85 over 2.945 is 4.8655. So, delta P is equal to 3.71 PSI per 100 feet. So, kita mo sa table. Ito. Yan. Riser 3 plus 4, i-add mo to. That is 1118. Nag-add siya, di ba? 3 plus 4 sa figure. Huwag natin balikan mamaya. Yan. Ang layo kasi. Yan. Nag-add siya. Okay? 3 plus 4, ito na yan. Mag-a-add na lang yan. So, 224 gallons per minute. So, the pipe size is 4 inches, type L. Its diameter is 3.905. Velocity is 0.4084 times 224 over 3.905 squared is 6.0 feet per second. The delta P is equal to 0.433 times 0.2083 times 100 over 130 is 0.1.85 times 224 is 0.1.85 over 3.905 is 0.4.8655. The delta P is equal to 1.64 PSI per 100. Okay? Mababa kasi yung velocity niya. So, for less than 6.8 ka talaga, bababa yung mga pressure pump. So, riser 3 plus 4 plus 5. Ang total niya is 2494 FU. So, 379 GPM. Pipe size is 6 inches type L. Its diameter is 5.845. B is equal to 0.4084 times 379 over 5.845 squared is 4.53 feet per second. The delta P is 0.433 times 0.2083 times 100 over 130 is 1.85 times 379 is 1.85 over 5.845 is 4.8655. So the velocity is 0.61 PSI per 100 feet. Kasi pag nag 5 inches ka, okay, papasok siya pala pag 5 inches. Pero wala kang nga mabibili. Mahirap pumanap ng 5 inches. Standard natin is nga 3, 4, 6, 8. So sa table, may makita ka 5 at saka 3 and 1. So wala yun na. Alisin nyo yun sa calculation natin. Kaya ito, pinagtang ko. Riser 2, 860 FU, 191 GPM, so 5 size 3 inches, type L. Inch diameter is 2.945. So the velocity is 0.4084 times 191 over 2.945 squared. That's 8.52. Yan. No? Delta P is 0.433 times 0.2083 times 100 over 130 is 1.85 times 191 is 1.85 over 2.945 is 4.8655. And delta P is equal to 4.81 PSI per 100 feet. The riser 3 riser is equal to 3 plus 4 plus 5 plus 2 is 3354 FU, 467 GPM. So 5 size is still 6 inches type L. Its diameter 5.845. So velocity is 0.4084 times 467 over 5.845 squared is 5.58 feet per second. Delta P is 0.43 times 0.2083 times 100 over 130 is 1.85 times 467 over 5.845. 467 is 1.85 divided by 5.845 is 4.8655. So delta P is 0.9 PSI per 100 feet. And answer 1, 1376 FU, 255 GPM. 5 size is 4 inches, type L. Inch diameter, 3.905 inches. Velocity is 0.4084 times 255 over 3.905 squared equals 6.83 feet per second. The delta P is 0.433 times 0.2083 times 100 over 130 is 1.85 times 255 is 1.85 divided by 3.905 is 4.8655. Delta P is 2.08 PSI per 100 feet. Okay? Last, riser 3 plus 4 plus 5 plus 2 plus 1. So total na. It is 4730 FU. So wala pa yung hot water dyan. 580 GPM. 5 size 6 inches type L. And the inch diameter is 5.845 inches. Velocity is 0.4084 times 580 over 5.845 squared is 6.93 feet per second. The delta P is equal to 0.433 times 0.4083 times 100 over 130 exponent 1.85 times 580 exponent 1.85 over 5.845 exponent 4.8655. The delta P is 1.24 PSI per 100 feet. This is for cold water. Next. Now for hot water, same formula is used. Riser 5, 96 FU, 43 GPM, type size na pumasok is 1.5 type L, and sa diameter 1.505. So yung velocity mo is 7.75 and delta P is 7.99 PSI per 100 feet. So, hindi ko nabasahin yung operation. Riser 3, 30 FU, 20 GPM, 1 1/4. So, its diameter 1.265, velocity is 5.1. Delta P is magiging 4.52 PSI. So, normally, sabi sa code natin is 5 feet per second pa ng 5 habang sa hot water. So, dito example lang ito. So, pag pinagawa ko nito, dapat So, assignment ko to, nideclare ko na 5 feet per second na at 8 feet per second sa cold water. Ito example lang to. Eh, huwag yung sabihin na, ito nga sir, naglampas ng ano, sinabi ko na nga, example lang yan. Dito sa libro. Pero maglalagay tayo na limit. So, riser for 48 APU, 20 GPM. So, pipe size is 114, type L. Inch diameter is 1.265. So, velocity is 11.15. Delta P is 8.41 feet per PSI per 100 feet. Riser 3 plus 4. So, this is now 30 plus 40, 78. Magiging 39 joules per minute. Pipe size 1 and 1 half. Type L. Inch diameter is 1.505. Velocity 7.03. Delta P is 6.67. Riser 3 plus 4 plus 5 is 174 cube, 60 GPM. Pipe size 2 inches, type L. Inch diameter 1.985 inch. Velocity is 0.4084 times 60 above 6.22 feet per second. Delta P is 3.85 PSI per 100 feet. Riser 2, yeah, 29 GPM, 1 in 5 size, 1 in 1/4. Inch diameter 1.265 inch. Velocity 7.4. Delta P is 8.98 PSI. Then riser 3 plus 5 plus 2, 234 FU, 72 GPM. Pipe size 2 inches type L. Inch diameter 1.95 inches. Velocity 7.46. Delta P is 5.39. Yan, nataas. Riser 1, 96 FU, 43 GPM. Pipe size is 1 and 1 half type L. Inch diameter is 1.505 inch. The velocity is 7.75 feet per second. Delta P is 7.99. Riser 3 plus 4 plus 5 plus 2 plus 1 is 330 FU, 91 GPM. Pipe size 2 and a half type L. Inch diameter is 2.465 inch. Velocity is 6.12 psi, a feet per second. Delta P is 2.9 psi per 100 feet. Yeah, better na. Now, the procedure for calculation is as follows. The static pressure for highest outlet is 180 times 0.450 as 77.94 psi. Ito yung height. Diba sabi 180 feet above the pump. Ito yung given sa problema. Pero sa actual, iisa-isahin mo yung per floor. Kasi may mga branch yun doon. Okay, may fittings. Okay. So friction loss, it is decided to size at uniform friction loss of 10 feet per PSI per 100 feet. So consider na i-assume mo yung uniform friction rate mo na 10. 1.5 times 350. So ito na yung kasama yung fittings pala ito. So 50% kasama, masasama mo yung fittings. That is 5 to 5 feet. So equivalent length of band is 10 over 100 times 5 to 5 is equal to 52.5 PSI. If 10 PSI per 100 feet ang ginamit mo, but actually, lahat ito below. So, sayang naman nung binaba niyan. So, required outlet pressure is 20 PSI. Mamaya, anis ka natin yun. Head loss to PRB at pump. So, natin mo sa catalog, 5 PSI. Total required initial pressure is 155.44 PSI. Ito. $77.94. Add ko muna. Plus 52.5 plus 20 plus 5. Tama. 77.94 plus 52.5 plus 20 plus 5 plus 155.4. Now, the total FU load combined and hot and cold is 4840. So, this is 580 GPM. So, the pump capacity and head can now be selected. So the total required initial pressure to. So 588 GPM yung pump capacity mo. Yung head mo, hanapin mo pa. Consider dito sa pipe size na 6 inches, type L, yung from pump to the ng hiwalayan ng hot and cold. Ang mo doon is 4840 and that is 6 inches ang pumasok. So type L, inch diameter is 5.845. Basic equal to 0.4084 times 588 over 5.845 is equal to 7.03 feet per second. So ito pumasok sa ating feet na 8 feet per second. So pwede mo isang makuha to. Equate mo sa 8, solve for diameter. So delta P is 1.37. For yung sa labas, bago pumasok ng pump, that is type K, 6 inches. Ang isa diameter mo is 5.741. So ang velocity mo 7.29. Delta P is 1 psi per 100 foot. Ito yung gagamit mong pressure drop doon sa pipe no. Mula sa labas sa pasok sa pump. Ito naman mula sa pump hanggang sa hiwalayan ng hot and cold. Kung hindi ka gagamit ng uniform friction head. Ito, so uniform friction head na 10 feet, ang lalabas mo total required pressure is 155.1. Pinesent lang to. So head on pump is 15544 psi. Suction pressure, since state pressure is 45 psi, by allowing for lower pressure during heavy load, we can use 35 psi, less 10, diba? Then 155.33, sorry, 44 yan, minus 35 is 120.44 psi head. So select pump for 588 GPM at height of 120 psi or 121. Now, the water service must supply 588 ppm. From the pump discharge to the takeoff or the hot water heater, the piping will be sized for the combined total hot and cold. Yan. Water load. And from that point, the rest of the system will be sized for the cold water load and the hot water load respectively. Friction head loss formula for type L tubing will be utilized. The tables indicate that 6 inches for a flow of 588 GPM from the pumps would produce a velocity of 7.29 feet per second and a pressure loss of 1.5 psi per 100 feet. So, consider mo yan. Pero sa problem na to, given kasi na yung length, so kaya di mo na siya ma-identify kung saan siya nag-take off. Pero sa floor plan, pag-gawa ng design, makikita nyo yung mga bunching. So, pwede gamitin mo na itong friction loss gauge. Okay? Hindi mo na pwede gamitin yung uniform. So dito, consider mo yung uniform. Pinasyon na sa una is 10 feet. Pero masyado mataas to kasi wala namang nag 10 feet na 10 PSI per 10, 100 feet dito, di ba? So, tinake natin to sa hot and cold water then. And cold. Yan. So, yan, may point line to 0.08. Yan. Okay? Pag tinake mo yung average niya, yan na yung three. So, basahin mo natin ito. See figure 6 for the schematic layout of the distribution mains in the basement, starting at the most remote horizon, work toward the source of supply. Table T5 for converting F2 to GPM and friction loss. Formula for selecting pipe sizes from the corresponding GPM flow. So, ginawa na natin, di ba? From the foregoing sizes required to maintain velocities at or below 8 feet per second, it can be seen that the corresponding pressure losses are significantly below the criterion of 10 psi per 100 feet. A much more realistic and economical criterion of 3 psi per 100 feet would not result in any significant changes in pipe sizes. 3. Pero ka nakita nun, di ba? 8, 9, dito. So, pag in-average mo siya, papasok siya sa 3, mga ganon. So, mas maganda ngayong isa-isahin mo siya. So, ito is ano lang. for demo. As a result, the head of the pump would be appreciably decrease. So, hindi ka pwede mag-assume na mataas, masyado mababa. Kasi nga, pag masyado mataas, so, masyado naman malaki yung pump mo. So, the total friction head loss would now be 3 PSI times 100 times 0.525 is 15.75 PSI. And the pump head would now be decreased by 52.5 minus 15.75 or 36.75 PSI. So, ito, babawasan mo ito ng 36.75. Yan. So, ilan na lang? Mga 90 na lang, yung mga 40, mga 80 plus na lang, 85 PSI na lang. So, laki na binaba, di ba? So, kailangan talaga detail. May example tayo ng detail pagkatapos ito sa sample design. So, dito, mag-asya muna tayo. Next is the suction tank. Suction tanks are constructed of riveted or welded steel plate. Sometimes, steel plate. The larger tanks often being divided into two compartments. They should be large enough to contain at least 1 day's supply for the entire building in case the city main is temporarily shut off. Yung case na to is para kung siya lang magsusupply. Okay? So the suction pipe from the pump to the tank should be across connected to the city main so that the water may be pumped directly from the main in case of fire. Yan. Ito kasing compartment na binanggit. Yung sa Bureau of Fire, yung reserve tank, kasama sa kabilang side siya. Okay? So, bira sa atin pa to. Suction tank are used so that pneumatic tank or other pump sucks the water from this suction tank and not from the public main so that it will not deprive the neighbor of water due to pressure. Kasi kung masyado ka mataas, yung kabila mo baba, kung nag-pump ka ng direct, mawalan sila ng tubig. So, kailangan meron kang tangke bago ka mag-supply sa building mo. Kaya ngayon, bawal na yung walang ganun. Saka yung dumi, quality ng water. This is for, sa reference tank. Tawag doon suction tank. Pero pwede ka lang maglagay ng tank. Yung sin na ito naka-underground, steel tank. Ayan. So, dito muna tayo. Next, 3 ways of water distribution. So, meron tayong upfeed system. From normal water pressure from public water or low rise building. Sa mababa lang. So, this one part. Water main, diretso, yan, pasok po sa mga floor. Okay. Ngayon, hindi na pwede ito. Kailangan mo na maglagay ng tangke dyan. Bawal ka na maglagay ng pump, diretso. Okay. Yan. Kailangan meron ka ng tangke. Sa ibang lugar, binabawal yon. Sa atin, yan, di ba? Kita mo, minsan madumi yung tubig. Kasi nakatap ka lang. Pneumatic tank. From air pressure from suction tank for tall buildings which cannot be reached by normal water pressure. So, the water tank or pressure tank, siyang mag-maintain ng pressure para hindi on-off yung pump mo. May delay. Okay? This is usually below the fixtures to be supplied. Ito, bumaba siya. When water is called for by the opening of any device like faucet, air pressure in the top portion of the tank deliver water to the system. A float operates the pump to make up this water when the level has become low enough to activate the starting switch. A high level switch turns it off when the water is up to the level. So ngayon, ang equivalent nito is yung pressure tank natin. Downfeed. Downfeed system by gravity from overhead tanks and are supported either by structural frame or on top deck. Fixtures are below the gravity tank. The elevated tanks are installed when normal supply of water from the main service tank is not frequent. It is also used when normal pressure from the city main is not enough to make enough depth to force the water to the highest textures. So yan ang tsura niya. Atas muna sa tangke, tapos bababa. So take note, ito yung last floor mo, pero dapat mga may distance yan eh. Para makuha mo yung pressure sa fifth floor. Kung nakahindi siya, kung equal ang distance ito per floor, pati roof deck mo, so kailangan mo ng booster pump pa rin. Okay? Para mapunta dito yung, tumama yung pressure niya dito. So residual pressure, flow pressure. Lalo na kung itong sa fifth floor, andun sa dulo yung outlet. May distansya ka pa, mga 40 meters pa bago mo yung outlet mo. So pag gravity lang, hindi yun naabot ko. So kailangan mo nang i-pump. So, pag yung kopya kayo ng kopya, sa drawing ngayon, sir, ganyan. Eh, na-check mo ba kung tama yung pressure? Ito kasi may distance to na 35 feet. Kung kasi kung 35 feet, papasok. Roof deck mo, tataas ka pa ng tangke ng 35 feet. So, makukuha mo yung pressure na 8 PSI. No need ka nang mag-pump. Kung yan lang sa baba. Next is the household water supply. Water is conveyed to the plumbing fixture by means of pipe. Materials commonly used are galvanized iron. Marami pa sa ating galvanized sa mga iba-ibang lugar. Malalayo. Pero sa sentro, Manila, ginagamit na is PPR. O PVC, pagkat water supply, pwede ang PVC. UPVC. And polychloride. Of any plastic pipe. Yung PPR, pwede rin. Pang commercial. Others are brass, copper, wrought, and cast iron. So, bira na sa atin yan. Mahal yan mga copper. The pipe from the public water main or source of water supply to the building service called the house service or service pipe. The vertical supply pipe which extend upward from one pole to the next is called the riser. And the horizontal pipe that serve the faucet or fixtures are called branches. So, may unti-unti na kayong sa term. Diba? Kung lahat ng term gusto malaman mo, andun sa plumbing code, sa mga code, tingnan yung definition of terms. Water main. So, in general ito. Water main refers to the public water system laid underground along the street where house service is connected. Yung water district. Tapos na papasok dito. Ewan ko kung meron din yan. O director lang tayo. Kung meron itong curb stop. Basta alam po, kinakabit lang. Tapos water meter na. Di ba? Tapos, sa water meter, normal na yan na may gate valve. Tapos, check valve dito para hindi bumalik yung tubig mo doon. Dito. Kung wala to, ibig sabihin, hindi na papasok yung tubig mo. Nagbabayad ka ng kuryente. Kasi umaanda ang kuryente. Tubig. Umaanda rin may tumoy. So, gate valve para i-close siya na maka-stop siya. So, dito, kailangan nyo itong pressure loss to water meter. Diba? Ano yung table na? Kung gamitin nyo ito pag ng pressure drop, kasi kung may pump ka dito, yung pump system mo dyan, kasama yan. Gate valve, pressure drop ng gate valve, saka sa check valve, plus yung water meter. Water meter, wala sa table natin. Doon sa plumbing code. So, ito, provide na lang tayo ng water meter, pressure drop. Minimum is 3/4. Normally, talagang 3/4, pero yung ibang lalagay wala. Now, capacity of the storage tank. The capacity of the storage tank may be taken as 33.3 to 50% of one day's requirement in case of overhead tank is provided. Yan. So 50 to 50% in case only underground tank is provided, and 66.7% in the UGT and 33.3% in the OH overhead tank in case the storage is provided both in underground and overhead tank. Ito ang rule, pero hindi naman ito atin susunod. Kasi yung iba, siyempre, sundin nila yung one day capacity, pag overhead tank, so lahat doon ilalagay. O hindi lang tank, pero tawag doon. Normally, pag overhead tank, i-require na sila na suction tank. Yun na lahat. Kahit meron ka sa rooftop, meron ka per sa baba for the purpose of suction tank capacity. So the capacity is 33 and one-third or one-third of 20.2% of total storage. Or one-third. Ito yan. Tapos yan, yung flow. Ito. So, ang purpose nito is kung ang target mo lang is overhead. Ito is backup lang. Okay? So, for underground lang, ito naman capacity mo. 50 to 150% in case UGT is provided. Bakit kulang? Asan yung 50? Asan yung 50? This is supply na to. Ang diagramming nito is meron kang direct. Yung iba, direct supply. Tapos, yung iba, i-store. So, yan ang ibig sabihin nito. Okay? Yan. Pag underground, ganun din. Kasi hindi lahat pupunta doon sa underground, gagamit ka na rin. Yan. Pero sa atin, linisin natin as a one day. Okay? Pero yung iba, siguro mag-require naman ito para makatipid sila sa tangke o ang tubig naman is malakas. Ang purpose ng mga storage nila, yung tangke is para doon sa peak period. Yan. Pero sa atin, sa walang tubig, ng araw, pero 100% na lang yan. Dito naman, ganun din. Pag mix, mas priority sa kanila yung underground, tapos konti lang yung overhead. Pero sabi ko nga, kasulatan sa atin, saan mo lalagay yung tanke? Doon sa taas para walang makonsumong space sa baba. So, ibig sabihin, mas malaki portion sa taas. So, ito yun, 33.3% of total storage. Okay. Steel tank. So, ito yung common na tanke. Pag ayaw mo ng concrete tank, so ito makikita nyo lagi. Steel tank has two configurations, the horizontal and vertical types. It is built with cylindrical stainless steel body at a rim for strength and rigidity, with a stainless steel dome top and bottom forming a capsule. It comes with solid steel stand and ladder for high load bearing strength and easy maintenance. It also uses polyethylene fittings for prevention of galling, which is common problem in metal fittings. Ang ginagamit ang vertical, ang ginagamit ang horizontal. Once the horizontal to, sa rooftop, dapat horizontal ka para hindi na masyadong mataas yung building mo, pa yung height. So ito naman, vertical, mostly sa baba, para sa yung space. Na? So, pero double check mo rin, baka kung sa labas ka ng building, okay yan. Pero kung sa loob ng building, check mo yung height. Pag kasi yung height, ito lang gamitin. Diba? Para yung space, maliit. Pag sa roof naman nga, ito, para din makita sa taas. So, ito yung mga proposed dimension. Diba? Ito yung standard ng gallows, 480, 500, 600. Yan. Ito naman yung vertical. So, dito, ang height niya, diameter and total height. Total height niya. Ano makuha mo yung length niya? Tinan mo dito yung length. Same size. Ayan, yung length na makukuha mo na. Okay? Kasi kailangan sa plano, puro drawing. Hindi mo pwedeng i-copy-paste sa plano. Polyethylene tank. So ito, meron din ito. Pamatagalan. Polyethylene water tank are used for water storage, water reserves for industrial and prevention purposes, and rain or waste water collection. These are safe containers of drinking water because the tanks are made of linear polyethylene, which is non-toxic material. Vertical and horizontal. Ito yung mga dimension niya. Capacity. Next, pressure tank. So, yeah. Pagkatapos ng dam mo, kailangan mo ng pressure tank. The pressure tank in a private water system has three purposes. It stores water and provides water under pressure when the pump is not running. It builds up a reserve supply of water so that pump start and stop less often, prolonging the life of the pump. In addition, it provides a reserve supply of water for use during times of high demand. Yeah. Ito bigyan yan. So, three types of pressure tank is the air over water, diaphragm, and ladder. They each do the job, but in different ways. So, ito yung Different type. Most common na yan is yung bladder type. Maliit. So, one compartment is stainless steel all star pressure tank. Yung luma to. Ito naman yung bago. Ito, diaphragm. Pag malalaki na to. Okay. Roll air over water tank. This tank use a single tank to hold the water and air charge. They usually have an internal coating to prevent corrosion. The term glass line or epoxy coated refers to the material used to line the tank and prevent corrosion. The air and water are in single tank with no separation. They're not as popular as they were, but are still used. The pressurized air pushes down the water on the water to create pressure needed to supply your home. While they tend to be larger than other types of tank, their capacity is similar to smaller tank. This could cause the pump to cycle on and off more frequently and lead to premature pump wear and failure. They can be prone to getting waterlogged due to air loss through pinholes becoming corroded. B. Diaphragm pressure tank. Diaphragm pressure tank have two chambers, one for air and one for water. They are separated by a rubber diaphragm that's permanently bonded to the inside of the tank, which rises and falls with the water level. As water is pumped into the lower section, the diaphragm pushes up into the air chamber, which triggers a switch that shuts off the pump. While this is an efficient system, it does have its drawback. One is having the diaphragm come close from the inside of the tank and letting water flow in the upper chamber. If this happens, you'll need to replace the tank. The other problem is having the diaphragm fold over itself and causing a false reading, which leads to premature pump burnout and tank being lowered. Letter C, the bladder pressure tank. The third kind of well pressure tank is the bladder pressure tank. This uses two separate chambers for air and water. The bladder is basically a large balloon filled with air that expands and contracts, triggering the pump. Since they are contained, they're self-contained, they don't have the issues of diaphragm or single chamber tank. Another advantage is that since the water and air are kept separate, air is not absorbed into the water and therefore there is no need to have air added. Air bladders also tends to last longer than diaphragm. They can have problems with water pressure or with short water pump cycle, which are usually because of problems with pump control, with well or pipe leaks, and sometimes less often a failure of internal bladder, which may be replaceable. Another problem is having the bladder get stuck into itself and remain inflated. This can cause rapid pump cycling. Sizing a pressure tank. Beginning the process of sizing a tank, there are few important input data points to know in order to properly size a pressure tank. One, the flow rate in gallons per minute, cut in and cut out pressure, target runtime. A general rule of thumb that most manufacturers suggest is a runtime of less than 1 minute if the horsepower is less than 1 horsepower. If the motor is over horsepower, then a good guideline to follow is a runtime of 2 minutes or more. Ito yung pag on-off ng ng pump, yung runtime na yan. Yung mababawas na tubig, mababalik na tubig. Always confirm this with your tank manufacturer of choice as guidelines can vary. Generally, as a rule of thumb, one can follow these guidelines with sizing a pressure tank. In terms of the flow, from 0 to 10 GPM, you must use 1 gallon of blowdown per 1 GPM of flow. 10 to 20, you should 1.5 gallons of blowdown per 1 GPM of flow. 20 GPM is 2 gallons of blowdown per 1 GPM of flow. Blowdown can be defined as the amount of volume loss in the tank as the plumbing system blows off the spent pressure. After all, the purpose of a pressure tank is to maintain pressure in a given system and give the pump a break. This way, the pump doesn't need to run constantly to remain at system pressure. While a pressure tank can appear costly upfront, it will save in the long run. Less runtime for the pump means less maintenance and less money in energy costs. Okay? Take note, 1 gallon of drawdown per 1 GPM of flow is 1 minute. 1.5 gallons of drawdown per 1 GPM is 1.5 minutes. 2 gallons of drawdown per 1 GPM is 2.2 minutes. Diba? So these are various orientation of pressure tank, and the most common are horizontal and line and vertical. Be sure to determine which orientation works best for your pumping setup. Once we have identified our flow rate in gallons per minute, we have identified our cut-in, cut-out pressure, and confirmed our target run time, we must determine what cut-in, cut-out pressure we want to set the system at. An important equation to remember when assessing a pressure tank is below. The flow rate times runtime is the tank flow downward capacity. Pressure switch setting. Yeah. The pressure switch setting is the pressure at which the pump turns on to fill the tank and the pressure at which the pump shuts off knowing the tank is full. The three pressure switch setting for pressure tanks are 2040, 3050, and 4060. So dito makikita nyo na, pag less than 20 PSI ka, huwag ka nang mag-pressure tank. The first number is the pressure at which your pump turns back on. And the second number is the pressure at which your pump turns off. The number that turns off the pump pressure is going to have the most direct effect on your drawdown. For example, if you have 40-60 switch, you are going to have less drawdown capacity than you would have on a 30-50 switch. Most well pressure tank manufacturer will provide you with a chart to tell you what your drawdown capacity is based upon the pressure switch setting. Drawdown is equal to P1 minus P2 minus P1 over P3 times P. So P sub 1 is the pre-charge pressure in PSI. P2 is the cut-in pressure in PSI. And P3 is the cut-in out pressure in PSIA. Absolute. B is the total volume. Attitude is at sea level. The tank pre-charge pressure should be at least 2 PSI gauge below the low pressure cut-in to prevent noticeable drop in pressure at the flex tube. So, for the online software, meron tayong Amcol solution online. Click nyo yan. Hanapin yung well tank sizing. So, andun yung sizing ng pressure tank. So, ito naman, yung ordinary makikita nyo, na standard dimension. In volume, itong volume, hindi ito ang drawdown na. So, ito yung may standard niya. Ito yung mga dimension. Kailangan nyo lagi kasi ng mga dimension sa fittings para pag-drawing. Kasi may fit na ngayon, pinapa-ISO pa natin na yan. Okay? So, dito naman, ito yung sa Amcol. Yan. Welex ang brand nito. So, ayan ang mga dimension niya. Okay? Check nyo lang sa brochure. Next, water pumps. Importante sa lahat, yung pump para ma-provide mo yung pressure. A water booster pump helps increase the pressure and volume of water that flows from your faucet or shower head. Life with low water pressure is a nuisance. If you've ever tried to shower under a trickle of water and had to turn in circles just to get wet, then you'll wear away. Low water pressure can make simple tasks like bathing or brushing your teeth a hassle, but a booster pump may be the perfect solution. Before you find information about what a booster pump is, how it works, how to size one, and the best booster pump for your application. So below, what is a booster pump? A booster pump is a device that increases low pressure and flow. It provides the extra boost needed to bring your water pressure to the desired level. A water booster pump provides pressure to move water from the storage tank or throughout a whole house or facility. What causes low water pressure? A. Gravity. Gravity either drives or slows water flow. The higher the elevation where water must be delivered, the lower the water pressure. Not to mention, 1 gallon of water weighs about over 8 pounds. If water travels uphill or up several floors, gravity wants to set it right back down. Building lower than their water source may not experience the same problem sa pababa. Skyscraper, apartment building, and homes and businesses with multi-stories require a large water pump to move water up many stories. Okay? Letter B, distance from the water source. Distance from the water source and the size of water pipe affects water pressure. If your home or business sits at the end of water supply line, the flow of water might be low by the time it reaches you. And if your water pipes are too small, a smaller amount of water will run through your fixtures. So ito yung sample ng water pump. Ito yung isa, mayroong pressure tank na maliit. So ito wala. Centrifugal pump yun. City and letter C, low city water pressure. So, madalas natin. Your house may be below the water supply line, your plumbing pipes may be clear, and you still have low pressure. Sometimes low water flow results from low pressure water from your local water plant. The additional water system. Additional water treatment system or other water fixture to your home brings you fresh water but may decrease your water pressure. Adding a booster pump can restore your water pressure. E. Plumbing problems. If low water pressure is the result of gravity, transportation, or other additional system, a water pressure booster may fix the issue. Other times, however, plumbing problems may be the cause. Now, before buying a water pressure booster, check your plumbing. The pipes may be clogged or the pressure reducing valve may need adjusting. How does a booster pump work? The booster pump boosts water pressure and in many cases improves the flow rate. A booster pump works just like a fan. A fan has blades that spin around it to increase air movement, and a booster pump has an impeller inside that increases water flow and pressure in the same fashion. What are the components of a booster pump? Most water booster pumps, no matter who the manufacturer, contain the same core component: the motor, so the impeller, the inlet outlet, the pressure or flow sensing device. Booster pump had an impeller that moves water that comes in through the inlet and exits through the outlet. A motor makes the impeller spin. Booster pump differ according to how they suck water in and push it out. Some water booster pump use a spinning propeller, while others use an oscillating diaphragm. Pumps with oscillating diaphragm propel water using two oscillating or rotating plates, one with cups and one with indentation. As the plates roll together, they compress the cups and force the water out. As the plates roll open, more water is sucked in. So, while a water booster pump enhances pressure and flow rate, a water booster pump increases water pressure, forcing the water to flow at a faster rate through plumbing pipes. But there's a pump curve to keep in mind. As the pressure required to move water increases, the flow rate decreases. Think about putting your thumb over a garden hose. As you do, water comes out at higher pressure, but the flow rate is restricted because of your thumb. A booster pump works in that same fashion. It provides the most water at the greatest flow rate under low pressure. If water moves out of the pump without any restriction, it moves at a greater flow rate. But when a pump is installed into the plumbing of a house where the water must travel uphill around vents and pipe to a kitchen faucet, then the flow rate is slower and the pressure from the pump is higher. How are booster pump used? Booster pump increase low water flow in water system or industrial equipment and transport water from a lake, pond, or storage tank for use in a home or commercial building. A household that doesn't receive enough pressure from the city water supply would need a pump to increase low water pressure. A hotel needs a large commercial booster pump to send water all the way to the top story. A booster pump is also used to repressure water from storage tank and send it to a faucet or throughout the home. In a rain harvesting system, for example, water collects in a storage tank. In order to use it to flush toilet or wash laundry, the water must be pumped out of the tank and into the house. You would use a booster pump to move the water. A home booster pump. A single water booster pump can boost water pressure throughout an entire house. Sometimes well water users can want to increase the flow from a low recovery wheel to their hose balloon. Low recovery wheel or source of water don't produce enough water to keep up with household demand. A water pressure booster pulls water from the wheel water storage tank to pressure rise the water in the house. A private wheel that does not produce enough water to keep up with demand requires a storage tank for the wheel to fill over time and a home booster pump from the tank to keep up with daily demand. Booster pump with an expansion tank. An expansion or hydrodynamic storage tank like pressure tank can enhance a boosted system. The tank gives water extra room to go when it expands and prevents the booster pump cycling on and off each time you turn the faucet on. Flow switch actuated pumps may hesitate to start on startup. A small expansion tank prevents this hesitation. A larger tank holds a volume of water referred to as flow down. This amount of water draws out of the tank before the pump turns back on. A larger tank can provide drawdown volumes in private well system to significantly reduce pump cycle. Do I need a booster pump? A booster pump is recommended if you have a low water pressure not caused by a leak or need to increase the water pressure for a certain application. Question to ask when shopping for a booster pump. So, nabay ko na to. What is my flow rate? Calculate how many gallons of water you get per minute, taking all features into consideration. Learn how to calculate flow rate. How much water do I need? Consider how much water your household or business uses. Is the water source above or below the pump? Think about whether or not your water must travel uphill or up several stories. How much pressure do I need? Many people prefer high water pressure when taking a shower, but that's too high can destroy plumbing, fittings, and appliances. Most homes have a pressure reducing valve where the water line enters the house to maintain the water pressure. Pressure over 60 psi where's the household plumbing system. Kasi sa atin is 80 psi. How do you size a booster pump? To size a booster pump for your specific application, ask this question. Do you have a two-story, four-bedroom, one-bathroom house? Are you moving water a significant distance? How far away is your water source? So pumps with a single impeller are not good at drawing water from a distance. If you want to use water from a pump for irrigation, then you need something with more horsepower to pump the water along the way. Water weighs 8 pounds per gallon, approximately lang to Alam mo yung, approximately lang yung 8. 8, it's a parang rule of thumb. Pero may exact value yan. Sa conversion nyo, yun gamitin yun, exact value, 7.85, gano'n. If water must travel up 1-inch pipe that climbs several feet, then the pump has to push a significant amount of weight. So how to keep your booster pump quiet? To keep a booster pump quiet, you need to factor in the type of pump used and materials around the pump is installed. Think about pump vibration during installation. The way you install a booster pump can enhance the noise it makes if you're not careful. Don't install the pump directly to copper lines because the vibration of pump will transfer to copper and sounds like an airplane coming to your house. Use a flex connector for the inlet and outlet instead to minimize the sounds from vibration.